We are going to discuss the solution of a differential equation when the roots are complex conjugate. So suppose a plus ib or a plus minus ib are the complex roots of a differential equation, then the general solution is written as y equals e to the ax, where a is the real part of the complex number and b is the imaginary part that goes with cosine and sine. So the general solution is y equals e to the ax times c1 cosine bx plus c2 sine bx. So we just want to prove it here why it is. Usually, if you think that your roots are like a plus ib and a minus ib, then you have seen the solution can be written as y equals e to the a plus ib x times c1 plus e to the a minus ib times x c2. All right. So then we know one theorem. It calls de Moivre's theorem. De Moivre's theorem. That one says e to the ix equals cosine x plus I sine x. So with the help of this de Moivre's theorem, we will prove that this solution can be written as this one, as you see here. Okay, so then this one you can split like e to the ax times e to the ibx c1 plus e to the a x times e to the minus I bx c2. Now in this case you can see e to the ax common factors, keep it outside. E to the ax, then we are getting c1 e to the ibx plus c2 e to the minus I bx. All right, so we'll be using our next step from e to the ibx and e to the negative ibx based on e to the ix equals cosine x plus I sine x. Now we are writing e to the ax c1. So e to the ibx you can write cosine bx plus I sine bx. This is the first part. Then second part I'm going c2 e to the ibx negative sign. So that one definitely you will understand, it is cosine bx minus I sine bx. All right. So this one is giving me now the complete ideas of the solution. Now we will do some simplification here. Now you can see c1 cosine bx and also you have here cosine bx. So you can factor out cosine bx and then remaining will be c1 plus c2. And then I'm taking plus now sine bx, I can factor out sine bx and remaining is c1i minus c2i. All right. So as you see here now, it is very simple idea that c1 plus c2 you can call a new constant. Call it c1 cosine bx plus this one here c1i minus c2i. This will be another new complex number, call it c2, and then you have sine bx. So when we are going to solve differential equation with complex roots, then we do not have to show all this work here. You can go direct to the solution that real part is a, so e to the ax, and then imaginary part has b, so you write c1 cosine bx, c2 sine bx, and that is the whole idea. Thank you.